Hello everybody, so today we're going to be dealing with Trigonometry chapter 22, exercise 22e, question number 18. So this question is a clear-cut question dealing with a figure which is of a kite and showing its dimensions of 4 centimeters and 10 centimeters and giving us an angle and wanting us to find out the angle ABC. So the basic concept that you need to know is that firstly that this is a kite because it has two pairs of similar heights, so 4 centimeters and 10 centimeters and 10 centimeters. So we know that if we draw the diagonals of this kite, they would intersect each other at 90-degree angles. So from here we can say that if this is ABC, then in triangle ABC, this is a firstly isosceles triangle because AB is equal to AC, and then AO, if this is point O, is the altitude of ABC because it's perpendicular to BC, and that if we draw it again ABC AO, then this angle would be equal to this angle and it would bisect the base into equal halves. So I've drawn this diagram over here by using the concept that I just told you. So this is 20 because 40 is going to be divided into two equal parts, 20 and 20. And this angle that we have to find out, ABC, is what we said is theta, and then it would be divided into theta by 2 and theta by 2 by the altitude BO. And then we can just see that if we have to find theta, then we can look at theta by 2. We can find theta by 2 by looking at the triangle BCO because it's a right angle triangle. So if we have to find theta, we have the hypotenuse. We just need either the opposite or the adjacent. We can't really find the adjacent here, so we'll focus on opposite. We can find opposite from this triangle because we have theta and we have one of the sides that is hypotenuse, so we can use trigonometry and find this side and then use this side to find this angle theta by 2 and then use theta by 2 to find theta. So first we'll look at in triangle COD, angle COD is a right angle because the diagonals of a kite intersect each other at 90 degrees. It's a right angle. Then you also need to say that angle CDO is equal to angle D divided by 2, that is 40 divided by 2, that is 20 degrees. And then you also have to state the reason because DO is the altitude of the isosceles triangle. So this triangle CDA. Now, once we know that, we can state that we know the theta, we know the hypotenuse, and we have to find the opposite. So we're going to be using sine. So we're going to say sine 20 degrees is equal to opposite upon adjacent, that is CO upon CD, that would give us CO upon 10, and this would make CO equal to 3.42 centimeters. Once we know that, we can move on to triangle BCO, and we can say in triangle BCO, angle COB is a right angle. Now again, once we have established that it is a right angle, we can say that we can use trigonometry here, and we can say let angle B is equal to be theta. Then angle CBO is equal to theta by 2 because of the same reason as stated above. And then of course the altitude is different, BO, and the triangle is different. And then we can state that we know the opposite, we know the hypotenuse, so we can use sine again, and we can say that sine theta by 2 is equal to CO, that is the opposite, upon the hypotenuse, that is BC. That would give us CO, that is 3.42, upon BC, that is 4. This will give us theta by 2 as 58.77 centimeters, and this will give us theta as, not centimeters, degrees, and theta as 117.53 degrees. And yeah, that's it.